Hi everyone, I continue on the lesson which is topic 5, graphing linear equations and just working with lines. So here, before I go to the second method of or third method of graphing lines, because the first method is table of values, which we did in the previous lesson, and the next one, which was the first one in this lesson, was using 2 points, x-intercept, y-intercept, to graph the line, and this is the third method. So before I talk about the third method of graphing, I have to give you some definitions and some explanations. For example, what is the slope, and so how do we use a slope to write the equation, and those things. A slope, a line, a slope of a line is the steepness of the line. If I want to just explain that on the graph, so I can say a slope of a linear equation can be found by just going from one point to the other point. So in order to see what is the steepness of the line. Okay, so when we travel or when we move from one point to another point on a line, we can see what is the change on y values. Okay, and we can call it rise. Okay, so I can show you on the graph. And also I can say, okay, so what is run? So run is the change on x values. Okay, when I travel from one point on the graph, on the line, to another point, of course you would know that each point has x coordinate and y coordinate, just a pair. Okay, so in both of them, so x and y, you have x and y in 2 points, and the changes on y, which is a vertical change, is rise, and the change on x, which is horizontal change, is run. So if I find rise over run, that will be the slope of the line. Okay, so I can keep this in my mind and I can use it. Okay, so for example, what can I say here? Okay, look at this line. Okay, so for example, I choose these 2 points. I choose this one P and this one Q. Then I say, okay, so what is P? So P is, look at that. So I do this and I do this. So P is -1 and -3, and Q is 2 and 3. Okay, so now I can say, if I travel from P to Q, so if I go from here to here, then I want you to tell me what is rise, means what is change on y values. Okay, so the change on y values is here. Okay, that's here, change on y values. Okay, so what is change on y values? Okay, let's just count it. Okay, so it is so the change on, yeah, it is 1, 2 and 3 and 4 and 5 and 6. Okay, that's the change on y values. Okay, so that's 6. How about change on x values? Okay, change on x values is from here to here, from here to here, and I can count this way. So it is 1, 2 and 3. Okay, so if I find 6 over 3, which is 2, that will be the slope of the line. Okay, so then you would say, how about if I change the point? I say, doesn't matter, you can change the point. For example, you can go from this one, okay, to this one. Okay, so what happened from this one to this one? How many change I have? Okay, my change on y values, which is here, is 2, and my change on x values is just 1. And if I say what is rise over run, in this case, for these 2 points, is also 2 over 1. Okay, so good news, if I use any 2 points, if I use any 2 points on the line, and I just see, for example, what is the change on y, what is the change on x for those 2 points, of course change on y is not the same as change on y for another 2 points. Change on x is not the same as change on x for another 2 points. But if I find rise over run or change on y over change on x, the result is the same for any 2 points. So it doesn't matter which point you choose. Okay, it doesn't matter. Okay, so what do we mean here when we say change here? Okay, so when I say change, I mean the largest minus the smallest. Okay, so or doesn't matter. So one of them minus the other one, but I have to keep that in my mind. Okay, so what happened here? Yes, I jumped in another lesson. Okay, so here, so look at that. So here, I want to show you what do I mean here. So as I explained here, so a slope is a steepness of the line, and if I use any 2 points, change on y over change on x shows how, so shows what is the, so what is the steepness of the line. And as you saw here, any 2 points I use, they give me the same slope for one, for the same line. Okay, so for example, I said, okay, for these 2 points, what is for example, what is from here, oops, what is from here to here? Okay, so oh my goodness, what happened? Maybe, yeah. Okay, so from here to here, see, I use this one, from this one to this one. Okay, yes, I counted 1 2 3 4 5 6. Yes. Okay, so can I say that's, so rise is, can I say rise is 3 minus minus 3? Okay, and how about run? Okay, so run, can I say run is 2 minus minus 1? Yes, so this one is 6 and this one is 3. You can see, this is 6 and you can see this is 3. Okay, so okay, perfect. Maybe I can say, I can write a formula for change on y and change on x this way. Okay, so rise is y2 over y1 divided by x2 minus x1. Then you would say which one first? So which point you use first? The upper one? How do you do? How do you know the one of them is upper, one of them is lower? But if, for example, you don't see the graph, what do you do? Then I would say, if this happens, it doesn't matter. You just have to pay attention. If you start from y2, for example, you have to start from x2 in the denominator as well. Okay, so it is the same as y1 minus y2 divided by x1 minus x2. Yes, yes, yes. Okay, see, I have here these two, and here. Okay, so I just have to, maybe I want to use something else, because I want to say this one here and this one here, again this one here, this one here, but I just want to mention this somewhere, so some other way. So I do this, okay, I do this, and I do this, and I do this. Look at that. So this is point P, this is point Q, and this is point P. Here is point P and here is point Q. So if you start from y of, for example, point Q top, in the denominator you have to start from x of the same point. Okay, so remember, I cannot do this. I can't. If I do y2 minus y1, I cannot say x1 minus x2. No, 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 no. It's exactly opposite. One of them positive, the other one negative. Okay, it's not. Because when I start from y2 in the top, I have to start from x2 as well. Okay, so before we move on to the third method, I wanted you to know the definition of slope. A slope means steepness of the line. For any 2 points, the change on y over change on x is the slope, which is rise over run. How much we go up when we move, when we travel from one point to another point, and how much we move horizontally. Okay, if I do it on the graph, that's acceptable. I can show you on the graph how many moves I have from up to down and left to right. And also, maybe I don't have the graph, I want to see formula. So this is formula here, which I made just here. Okay, this is the formula here for the slope. If I don't see the graph, so I can use this formula. Okay, so we do some examples and then we continue. So find the slope of a straight line that drops by half a unit as it moves 1 unit to right. Okay, so see, it says drop. So drop, when it says drop, it's up and down and goes to right. Okay, so this means, okay, so do I have, maybe I have to zoom it. Okay, so drops here, this, and right here. Okay, so a slope is -1/2 divided by 1. The reason is negative because it says drops. Okay, just like coming down, or so like reduce, so drops 1/2, and as we move to right. Okay, so and I always have to go to right. Okay, so I always have to go to right on horizontally, but I either go up if it's positive, I go down it's negative. I will show you. Okay, so how about here? Find the slope of this line. Okay, I told you you can choose any 2 points. You can choose any 2 points and use the formula in order to find the slope. Okay, here what did I do here? So we just talked about a slope. Just verbally, I just said definition of a slope, then I show it on the line. I use it for two different points and I saw the same result, and then I find the formula here. Now I want to use the formula to say what is the slope. Okay, so a slope is rise over run. Rise means change on y over change on x. Mathematically, when you see delta, okay, wherever you see delta in physics and math means change. Okay, that's a symbol for change. So okay, delta y over delta x, what does that mean? Okay, change on y2 minus 1 x2 minus x1, or y1 minus y2 divided by x1 minus x2. Remember, if I start from y2, I start from x2 in the denominator as well. If I start from y1, I start from x1 in the denominator as well. Okay, so I said I can use any 2 points, but when I give you something like that, you have to make sure to use a point which are sure about x-intercept, sorry, about x coordinate, y coordinate. Okay, so I do not use any 2 points unless I am sure about x coordinate and y coordinate. So I use this and this. Okay, so what is this? This one is 0 and 10. This one is 2 and 30. How do I know? Okay, I know this and this. I know this and this. Okay, so perfect. So a slope is 30 minus 10 divided by 2 minus 0, which is 20/2, which is 10. Okay, so 10 is just a slope of the line here, and I can show a slope of a line using just m. Okay, that can be m. So I can say, okay, m is 10. Okay, so when I'm talking about lines, for example, and I say m is 10, I know it's a slope because I use m for the slope. Okay, so that's the that's a letter that we use. Okay, so look at here. Okay, so yeah, now the third method of graphing. The third method of graphing is slope by intercept. Sometimes I feel it's challenging for a student, but no, if you know what to do, it's not really challenging for anyone. So if you learn what to do here. Okay, so what is the slope? So as I said, it's okay, so I can maybe write it here for you. Okay, so oops, yeah, okay, just to make it easier, so maybe I do here. Of the line, oops, of the line. And how about y-intercept? Okay, so y-intercept spot where the line crosses y-axis. Okay, so pretty good. Yeah. Okay, so so the next step here. Okay, so maybe I can change the color. I'm just thinking this will be good, and this one, no, I don't need to have this here. Yeah. Okay, so now I want to talk about the third method. Okay, what was the first method? The first method was table of values. So I give values to x, I find y, I have 5 points, I find the points and just connect them. The second one, I find x-intercept, y-intercept, I know how to find x-intercept, I know how to find y-intercept, and I just connect them, right? Okay, so two methods. This method here, for this method here, I can say this method seems challenging for a student, but if you really learn it, it's very easy and it's very useful because it's very fast. Okay, so you can really find your just you can graph the line much easier than other two methods. Okay, but if you know what to do. Okay, so let me see here. Okay, so 1 second here. Okay, I just had to see something. Yeah. Okay, so I find for this method I find y-intercept first. Okay, so I find y-intercept and then plot it. So you touch y-intercept on the graph. Okay, so y-intercept is on y-axis, so where the line crosses y-axis. Okay, so then use the slope to determine the second point. Okay, so this part I can say is a little bit challenging, but if you learn it, it's even fun and very easy. Okay, then when you find the next point, you can connect these 2 points because you have 2 points and you really need 2 points. Okay, look at this here. See, it says there are a line which is a slope is 2 and y-intercept is -1. Okay, so what did I say here? I said you have to find y-intercept first. Okay, so I go here, I do this. Okay, and I find -1. Okay, so then what is the slope? See, this is the first step. Find y-intercept. What is the slope? A slope is 2. Okay, so a slope is 2 means rise over run is 2. I can say it is 2 over 1. When I don't see anything in the denominator, it means 1. Oh, okay. So I can say if I start from 1, sorry, if I start from y-intercept or -1, I can say I go 1 unit to right, I go 2 units to up. Okay, so I start from here. Remember, I don't start from 0. Sometimes I see a student start from 0. No, you have to start from y-intercept. Then you go 1 unit to right, but then you have to say, so which one is 1 unit? So this is 1 unit and this is 2 units. See, I say 3 by 3 because I have a space. Okay, but if I go 3 by 3 for x-axis, for example 2 by 2 for y-axis, so here I do 3 by 3, here I do 2 by 2, so I continue the same way for the whole axis. Okay, so I go 1 unit to right because it's over 1, and when I do that I go 2 units up, 1 2. Okay, this is my next point, and now I connect them. Okay, yeah, good. So the first method is table of values. I give values to x, I find y using my equation, I find those points and connect them. Then the second one is x-intercept y-intercept. I give y equals 0, find x, x equals 0, find y, find those points on x-axis, y-axis, and connect them. The third one is faster, but you need to know what to do. First, you find y-intercept, then look at the slope. A slope, whatever number you see, you have to see what is rise and run, positive or negative. News, good news. I can say, we make agreement. I always go right for run. For run, you always go right. Why? Because if I have minus a over b, for example, I have minus a over b, I can say this one. Okay? So I can say it is a over minus b, but so it's not really common. Okay? So I can keep minus for up. Okay? So I always think that run is positive. Okay? So I always go to right because I look at run, and from y-intercept I go to right the same number as run. Then I look at rise. If rise is positive, from there I go up. Okay, see, I start from here, I start from here, I go 1 unit to right, I always go to right. If negative, I go down from there. If positive, I go up. Because it's positive, I go 2 units up, then I find the next point. So this is my next point. Okay, and now I connect them. So we can go here and look at this example. This method is useful for this kind of examples. When I have fractional slope, okay, and it's very hard, not very hard, not impossible, but time consuming. See, if I say, for example, my equation is, for example, it has minus 4 over 9 as a slope. And so if you want to do with, you can see this later when I write the equation. If you want to do with table of values, it's time consuming. You have to give values to x and calculate, and it has fraction. It's hard to calculate. Not hard, it takes time. The second one, x-intercept, y-intercept, again, it takes time because you have to solve because it's fraction. But if I tell you I have y-intercept equal 1 and the slope is minus 4 over 9, remember, when I say minus 4 over 9, I can say minus 4 over 9, okay? I know I can have minus in the denominator, but it's not really common, so in this case I don't do it. Okay, look at this. I can graph this very fast. Okay, so first of all, oops, I need to find 1. Okay, so but I have to keep in my mind that when I look at my, before I just graph it, before I find y-intercept, I have to look at this. See, I need to go 9 to right. I need to go 4 down. So I write this way: 9 right, 4 down. Okay? So, why down? Because it's negative. Why right? Because I said for run, I always go to right. Okay? If I have negative, I just go down. So I just make the effect of negative on top of the top of the fraction. Okay, so before I start my graph, before I start the graphing, before I find my y-intercept, I do look at the rise and run. Okay, so I need a space. I need a space to go 9 to right, and I go 4 down. Okay, so I go here, and I go here. Okay, so this is 1. I start 1. I need to make sure I have room to go 4 down. Yes, I do 1, 2, 3. So 1, 2, 3, 4. Yes, I have. And I need to make sure that I have a space to go 9 to right. Okay, so you look at your slope and see how many you need to go to right, how many you need to go to down, and then start graphing. Because otherwise then you have to maybe you don't have a space for going right or down, and then you go out of the graphing paper, and we don't want that. Okay, so at the beginning I decide about my graphing method. Okay, here I decide, here I want to show you, but here I decide, when I look at fractional slope, I decide the third method is very good for me because I don't need to do so many calculation. Okay, if I want to do table of values and x-intercept, y-intercept, it's not impossible. Of course I can, but it takes time. I have to do calculation. The more work, the more chance of mistake. Okay, then I look at my rise and run. Okay, so I need to go 9 to right. I always go rise. I always go run to right. For run, for denominator, I always go to right, but depends on positive or negative, I go down and up. Okay, so I need to go 9 right and 4 down. Okay, I need to have a space. When I make sure that I have a space, then I graph my line, and just I graph my line such a way that I can go 9 to right and 4 down. So I find y-intercept first. Okay, I have y-intercept here. Then I look at here. I go 9 to right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I go 9 to right, and from here I go 4 down. But remember, here I have to show this is 1, this is 2, and in this case I know here you go 1 by 1, here you go 2 by 2, because you have a space. Okay, so 9 to right, and then 1, 2, 3, and 4. Okay, so then I find the next one. So one of them is here, which is 1. This is y-intercept, and the next one is here. So now I connect them. Okay, so this method is good for fractional slope. So first you decide about the method, and then you look at the slope, how many right, how many down or up, down, negative, if you have negative down, positive up, then you have to make sure you have a space. Then you have to see, for example, for x-axis you go 1 by 1, because you need to go 9 to right, and for y-axis you go 2 by 2. Okay, you can show, for example, you have to show, otherwise I ask, how do you know it's one unit? Okay, so this is 1 here, this is 1 here, so this is 9 here. Okay, so then I can show you I did 9 to right and I did 4 down. Okay, so I want to see here, you choose that, you select Y intercept. I want to see your run, I want to see rise or so up or down. Okay, I want to see the next point and I want to see you connect the 2 points and then you have the line. Okay, when I say show me on the graph, I want to see these arrows, just 9 right and 4 down and these things. Okay, so now I want to just, as I just did there, I want to come up with a just formula and I want to explain the formula more. Okay, so if I have 2 points, x1, y1 and x2, y2, yes, I did. Okay, so I said slope is rise over run. Okay, so I just accept a slope is, because I just defined here, a slope is rise over run. Okay, so rise is change on y, so it's delta y over delta x. What is delta y? So change delta y is y2 minus y1 and delta x is x2 minus x1, and then I can write the formula here. Okay, but I want to emphasize y2 minus y1 over x2 minus x1 is good. y1 minus y2 over x1 minus x2 is also good. Or I can do y1 minus y2 and, for example, x2 minus x1, but I have to say it's not equal. Okay, this is not a slope. Okay, that's not a slope. Okay, so make sure don't do this. Okay, so maybe I can just do it here. So I can just say a slope is not y2 minus y1 over x1 minus x2. Okay, if I start from 1 point here, so I start from y of, for example, y of 1 point, I have to start from x of the same point in the denominator. And if I do this, yes, and this one here and this one here. Okay, yeah. Okay, perfect. So now, as I repeated the formula, I had it before, I talked about that before, but now I wanted to just explain it again. Okay, so that's my formula here. I have to emphasize. Now I can work on some questions. Okay, so see, I don't give you the graph. I just give you 2 points, and you are able to find the slope for me. Okay, so we really have to be careful. If I have the graph, it's easier for me because I can count, but here I have to calculate. Okay, so the slope, which is m, is 4. Oops. Okay, so yes, so it's 7 minus 2 divided by 3 minus 4. Oops. Or it is 2 minus 7 over 4 minus 3, which is, for the first one is 5 over minus 1, which is minus 5 over 1, and which is minus 5. Okay, that's the slope, right? How about this one here? For this example, doesn't matter. I start from this, minus 6, minus 4 over 5, minus 3. Be careful here. I have minus 3 because I already have minus 3. So I do minus minus. Don't forget. Okay, so it is, or I can say 4 minus 6. Okay, so this one is minus 10 over 8, and this one is, okay, so I start from 4, so here I start from this, which is 10 over minus 8. That's minus 5 over 4, and here that's minus 5 over 4 as well. Okay, I should have to I should reach to the same value, otherwise I'm making mistake. Okay, yeah. And again, I want to mention If I have minus 5 over 4, it's the same as minus 4 over 4, and it's the same as 5 over minus 4, but it's not the same as minus 5 over minus 4. Okay, this is sometimes I see this mistake. No, if you have one minus, you don't distribute minus to up and down, because this is positive. This means 5 over 4, not minus 5 over 4. Okay, good. So now I can stop here and I can continue after. So this is the end of video 2. Here we are going to talk about, and I can continue, but I'm thinking I need your mind just fresh and good for this, because it's not hard at all, but just it shows you something interesting um, and fun. Okay, so I continue after. Thank you so much. Bye.